Hello, can you hear me? Thank you for staying so late here. Being last is always very difficult. My name is Wallace. I'm part of the Global Solutions Group. I live in Houston, Texas, and I lived in the Gulf Coast here for the last 35 years, and my background is in chemical engineering, and I've had many years experience in the petrochemical business. Today, I would like to focus on two topics here. Is just a second. I want to talk about the Shale Revolution and how the changes in the natural gas business in North America has really changed the petrochemical industry. And then I'm going to follow up and talk about what I've seen in the Gulf Coast here in the last 5 to 7 years in the petrochemical industry, the topics that I've seen that are trending. So the things in the chemical industry that I've seen here in Texas, in the Gulf Coast, is trying to deal with a mature market in the chemical business where the growth is slow and it's a mature industry. Energy management is very, very important in the chemical business. I will have some use cases in talking about energy management. Talk about the product quality. I won't deal with the last topics because of time, but these are just things that are trending in the chemical industry as product quality is becoming very, very important. Looking at yields from our assets like equipment, looking at monitoring the assets. Regulatory compliance is becoming more and more difficult to work in the U.S., trying to comply with U.S. laws for environmental compliance. Knowledge retention is a big issue in North America because of the aging workforce. We have an age gap where the people who understand how to run chemical facilities are aging out, and we don't have enough young people coming in to fill in the gap. So there's this drive or need to try to figure out how to retain the knowledge of the people who know how to run our chemical facilities, and how do you capture that, because we have to train the new young workers coming in. And the standardizing in architecture. The chemical business is a buy-sell of different companies. In the last 15, 20 years, you have a company that bought A, then buy C, and what you end up having is different standards of naming conventions, architecture, equipment, and vendors. And that's what we deal with in the chemical industry. So I mentioned that there's limited amount of time. So what I decided to focus on, I thought would be relevant for this audience, is looking at the low growth. What are the chemical companies doing in North America to focus on and deal with the mature market? And there are two things that I see that's actually programs that are coming out. It's called abnormal situation management. So people in the refinery business, this is a very common term. You guys have seen ASM, you talk about it. And I have my personal experience as a chemical engineer on how we deal with ASM in a concept called situational awareness, or you might hear called operational excellence. And then I thought, I just came off of 2 recent projects. This energy management is very important. I wanted to give you a use case of one company that I work with, one of my clients is biomaterial science, and how they deal with energy management. And the second company, which I worked with, on how to solve almost the same problem, but then show you how we use the latest tools that was just demoed here in the previous talk. So this is just a slide on showing you the oil and gas value chain, where OSI plays in the whole value chain, all the way from to production, the midstream, the LNG, the hydroprocessing, and biofuels. You see kind of where we're at. 2 of the notable Japanese companies with Mitsui and Sumitomo. They're part of our important customers here in the Japanese market. This is an interesting slide here, rest in peace. When it was not that many years ago when we thought in North America that the whole chemical industry was going to die. We were talking about building facilities to import natural gas from the Middle East. No one was making investments in the chemical industry. There was just really, we thought that the chemical industry was going to fade and was going to all go to the Middle East. I was even telling my children, don't study chemical engineering because there'll be no jobs in North America. But things change. And what has changed since 2008 and 2009 is a thing called the Shale Revolution. It has totally changed how we view the chemical industry because of this technology. This is just I've attended many conferences here in North America, and this is just a slide of a conference I attend. You'll see, you can find many presentations that's talking about how Shale has actually changed and revolutionized how we deal with the chemical business. And what's changed is the fracking technology, the technology to be able to get more natural gas out of previously fields that we thought were dead. There's been many fields in North America that we thought was already played out. There's no more way to get any more natural gas. But this technology has changed that thinking. This graph on the right here, talks about where global shale is around the world. But I wanted to give you what we call the enablers of why North America is different than all the other places you can get shale. And the main drivers for that is what we call the enablers is we have the infrastructure, the pipelines, the petrochemical complex, and something that's really, not really thought about a lot is we have the ability for mineral rights so that people in North Dakota, Texas, Kansas City, Kansas, they own the rights to sell to the oil and gas companies for them to drill, to allow them to build a pipeline. So those combination of factors gives North America, I think, a competitive advantage to be able to extract the natural gas out of the North America markets. So this is kind of a summary slide. What's the impact to the shale production? I wanted to emphasize the area like in Pennsylvania. For many years, Pennsylvania, they thought was dried out. There's no way, no one was making any investments. And within 3 years of using fracking technology, they were able to exceed the North Sea gas production with 3 years, from going to zero to exceeding that part of the world. The things that I thought may be a short-term supply, they're projecting over a 100-year supply. As I go across North America and I go to West Texas, I'm seeing massive capital investments because this is not a short-term trend. This is over a 100-year supply that they're projecting. And the evidence that the people are putting bets on that is the amount of money that you're starting to see being invested. There's over $100 billion of investment that they're putting into facilities development. What's the end result of all this? This is just yesterday I wanted to know what the Henry Hub, that's the spot market price in natural gas. So you'll see at the time that I thought that the chemical industry was dying from 2000 and 2008, wasn't sure that there's a steady decrease in the natural gas supply cost in North America, and it's around $4.50 right now. So that's what we're seeing here is a steady decrease in natural gas pricing. So how does that actually kind of impact for this seminar? What is the impact here to East Asia? What is this low-cost supply? How does that impact the Japanese market? So this morning, or yesterday morning, I also did a price lookup. What is the cost of natural gas here to import natural gas? It's around $15.23. That's about what the price is yesterday. And what this is saying is that natural gas is a fuel of choice. And recently it's becoming a price competitive fuel option here. It's something that from North America is viewed as a safe and reliable supplier of natural gas to the East Asia market. The only little change that I had was that in the last year there's been kind of a surge in price in natural gas. So if the trend keeps going up, it might change the dynamics so much that you may have to look at alternative sources for fuel. Look at something besides natural gas. If the trending of this continues, is what I'm seeing. But currently, there's still enough gap here. So if you're paying $15.23 per million BTUs now, it costs about 9.4 to 9.6 million BTUs for the U.S. to ship the gas down to the Gulf Coast, gasify, put it into liquid form, ship it over. It's about 9.4, 9.6. So there's still enough gap in there that major companies are putting investments to put enough capital in there to put this bet that this gap will still continue for the future. So this is another view of the oil and gas industry, and I wanted to concentrate on the upper side of how the gas flows from production all the way to the market. And this is a little bit more of a detailed view here. So we talked about the spread here in the East Asian market being worthwhile for people to make that investment. Enough investments that they're putting all this investment into the pipelines and the facilities to compress the gas here in the Gulf Coast. They're playing catch up. They're still making some investment here to increase the capacity to create LNG to the East Asian market. We're still playing catch up on that. Now, in East Asia here, what you'll see here is that most of the investment that we're starting to see is in the transportation of LNG, the creation of the gas regasification here in terminals here in the East Asia market. And that's something you guys have evidenced and see over here. So we're entering for the next several years, because the gas supply is so abundant, really a global trading market here to build the infrastructure for natural gas. That will continue here, and the pace is increasing. So I wanted to now go to the petrochemical trends here. We talked about the industry challenges here, and then I said I wanted to focus on the energy management and the mature markets and how companies are dealing with these mature markets. And the first one is this thing that's a very common term in the refinery business called ASM, abnormal situation management. And just a little definition of what is abnormal situation management. It's something that you didn't take account of. It's not something that you developed in your control system model, and it occurred. You didn't know what's going to happen, but it happened, and it causes impact to your business. That's what an abnormal situation is. You didn't know it was going to happen. And it could cost you money. So in the refinery studies here from the Honeywell groups as I went to, it could anywhere be from 3 to 8% impact to your capacity, and you have to kind of define what is that incident, what does that it mean to your business to lose 3 to 8% of your capacity. The learning points here about abnormal situation I want you to take away is that you have to design an abnormal situation and framework for not only what is normal in your process, but what is abnormal. You have to basically look for adaptation because your process is always constantly changing. So you have to have a flexible system that you can quickly change your infrastructure controls and information as your process changes. A high-level framework for an abnormal situation is some of these components. And where OSI plays in is that we're part of the data acquisition part of an ASM, the monitoring of the process variables, and the diagnostics of it. So those are the bubbles I kind of highlighted where we play. And one way of doing this situational awareness of an ASM solution is called operational excellence. That's where some of the companies that I worked for basically is looking at operational excellence to implement an ASM framework. So here's the case studies here. So low growth here, looking at the operational excellence, the bubbles in the purple is where a lot of the companies are at. They're at the purple side on the low-end side. They're getting data. They're doing ad hoc analysis. They're looking back in time and asking questions, what happened? And to really start getting into value and handling these abnormal situations is start asking the green questions. What will happen? And what could be the best possible performance in the future? So the green is where we all want to go to in an operational excellence framework. This is just a screenshot of the presentation. My former company where I worked at Lubrizol for 11 years as a process control engineer, and they implemented a operational excellence program here to try to take advantage of some cost savings and improvements that they can make. So I won't read all the great details on here, but they looked at tuning optimization,
最適化をして
save money in their plants, and these are just a few of the cases we worked on that's been documented. But the takeaway here is that I want you to get from that, the last bullet item is that they had a abnormal situation framework called operational excellence. They were able to merge process data, batch data, lab data, to do the analysis that you saw kind of in the previous demo using our products Excel and using the data link. Just another example of a company that's looking at operational excellence is Pemex. They wanted a corporate-wide window, a view of looking at all their assets and measuring the performance here. And Pemex has developed a corporate-wide monitoring system to look at the performance of all their assets. And then we followed up, my partner in Houston followed up on the same Pemex to solve a problem. They had an inventory reporting problem. So when you have refineries here, you have to put factors in when you want to do production reporting. So they wanted a way to gauge the reported production versus what the system actually is reporting and do a variance. So we used our latest technology using Pi Analytics to calculate the actual production versus the reported production and to see what the errors were. Now, switching now from looking at operational examples, I'm really, this project I was working on for just recently as last month, we were invited to a company that had these typical energy management questions. What is the current energy usage divided by production? They want to know how efficiently are they making a product and how much energy they were using. Can they compare the current energy usage versus the best performance they ever had? So they now have a reference point of what they think is the best performance versus their current energy usage. Then they ask us, well, if we know that data, what is the waste or the loss that can be calculated because we're not running as efficiently as possible? So once you have the data, next step question, and when you're looking at plant, they want to know is which assets, which in this case is motors, which motors are consuming the most energy? So I know they're not running optimally, but I have all these motors. Which one is consuming the most energy? If I also know that, then we can calculate how much money could we possibly save if I had all that data. So these were the business questions that was given to a challenge back in June. They said, these are our current problems. We will give you, in my new group here, access to our real data. Tell us what we can save. Tell us which motors are what they call bad actors that we need to address. So the first example is how we solved it without the new technology that was previously demoed. I worked with one of my clients with Bright Material Science, and they had the exact same questions 6 years ago. They wanted to know, what is the awareness gap? They have a baseline of what is the best possible energy consumption. They basically have documented that. With the current projects, what is the gap? How much could we save? And using the older technology, they were able to trend, by looking at process book and trend as in the previous demos, calculate the error between the best operation line versus what they're currently running. That's called the loss or their awareness gap. So they could basically see that through their trends. A better way of doing it is what we proposed back in June to another company is, why don't we use our latest technology? So all the technology that was demoed before, we used most of this technology to try to solve this equation that Bayer did with the latest technology. And here's the results. This is back in June, July. This is very recent here. This is the end result using Power Pivot of all the data that we collected from their plants in real time. And I tried to address all the business questions that I discussed earlier. So the first question they wanted to know is, we have multiple parts of the plant. Pick one plant. So we do what we call the slicers. So if I drill into one part of the plant, in this case it's called Refinery, it then allows me to select a sub-part of the plant. They call it a unit. So by selecting the part of the area that I want to drill into, it tells me what units I can actually select. Now, all these slicers, it might not be evident, is part of the AF model that was demoed. So I'm able to get all this information because I spent the time up front to model the plant. And all these ability to slice or analyze is now part of that AF model. The next thing they want is they ask me questions about which motor do I want to analyze. So I had to bring in all the AF motor elements into my slicer. So I have a list of all the motors that I want to slice and dice and do the analysis. Another part of the analysis is what was the time frame I wanted to analyze. So we were capturing energy production events, put them into event frames, and now it's part of my slicer, so I can pick the current time or any other time frames that I wanted to analyze my energy usage. And this is really key for the reliability guys, because we're talking about hundreds of motors at this facility. And then you had a limited amount of time. You can't work on every one, so you have to be selective about which motors you want to attack. So what we have is, I made this up here, I call it small, medium, large. In the real data, they have their motor size rating, so you'll have a lot more categories. But for this demo purposes, I just made 3 slices to make the point that you can select the size of the motor that you want to do the analysis, because the large motors are the biggest energy consumers, so you only want to spend time on the ones that's going to cost you the most money. And the result is this graph here. What we found out was that zero is baseline. If you're at 0, that means you're consuming the energy we expected you to consume. If you're above 0, you're consuming more than we expected you to consume. So what this analysis says is that those motors to the left are something you should investigate. Why are they using more energy than we expect? The data on the right says this value is too large. There's something wrong. So the instrument engineers, you need to go back to this data points and check your instrumentation. It can't be that large. So just by doing this analysis with real data at a facility, we can answer some of the questions of which motor should you be looking at? Which ones possibly has instrumentation problems? And this is all unfiltered data. So we were working with bad data, and we just, whatever came in, we just basically said, this is what it looks like. The other question they asked was, we don't have time to do this ad hoc analysis. They said, Young, that's really nice, but I'm very busy. When I come in the morning, I just want to know one question. Give me the 10 motors that's the most energy consumers for all the areas in the plant. And we'll just call them bad actors. So the maintenance engineer said that's what he wanted. So using data link, we just created this. It took just about 15 minutes to create this because I already had the model developed in AF. I had the events all modeled for me. I can ask just one question. I asked, give me the top 10 motors or high energy consumers for the last 7 days. And this is a list now. This is a report that the maintenance engineers will come up in the morning at 7 a.m. and work on this list, because that's what they wanted. But I guess the point of all this is we made the investment up front to model this, to ask these types of questions. This is just one example of the questions you can ask, because we have the data. Questions? That's it.